Okay, so we have two parametric equations, y equals sine theta and x equals cos theta. The equation that links them both is going to be x squared plus y squared equals 1, because we know the identity sine squared theta plus cos squared theta equals to 1. Now we know for part 2 of the question, it says the periodic sequence is defined by u of n equals to minus 1 to the power n. Now if we substitute n equals 1, we will get minus 1. If we substitute n equals 2, we get 1. So the difference between them is going to be 2 terms. So the period is going to be 2. Now with question 3, since it's transformed by a scale factor 2 parallel to the y-axis, it's going to be y equals to 2 log base 4 of x, because it's 2 times f of x. Now question 4, we're given this quadratic y equals ax squared plus bx plus c, where a is less than 0 because it's a negative quadratic. So if we find the gradient, we will get minus 2ax plus b. So the graph would look like this, or the linear graph. With question 5, we need to find the equation of the tangent y equals to x minus 2 all to the power 4. So we use the chain rule. So we know the inner bracket differentiates to 1, so it's just going to be 4 bracket x minus 2 to the power 3. We substitute x equals 0 to find the gradient to get minus 32. We also need the y coordinate, so if we substitute back in here, we get 16. So our equation of the tangent is going to be y equals to minus 32x plus 16. Now question 6, we need to find the first two terms. So we're going to use binomial expansion. So we're going to have 1 plus nx. So it's going to be 1 plus a half multiplied by minus x over 2, which simplifies to that. And then with part B of the question, it says show for small values of x, show that sine of 4x plus the square root of cos x is approximately these three terms. So we know that sine of x approaches x, therefore sine of 4x is going to approach to 4x. And we know that cos of x approaches 1 minus x squared over 2. So if we find the first two terms, because it's a rational power, if we find the first two terms, we get up to the x squared term. Well, not the first two terms. We need the first wait, no, it wouldn't make sense. We need the first two terms, because if we find the first three terms, we'll get x to the power 3 term, which we don't want. So if we do that, we get 4x plus 1 plus x squared over 4. So if we simplify that, we get 1 plus 4x plus x squared over 4. Now with this question, we need to sketch y equals cos of x minus pi over 2. So if we draw the tan graph, we get the black line. And if we reflect it in the x-axis, we get the blue line, which is cot x. And we know that it's translated on the x-axis by the vector pi over 2, 0. So if we move it pi over 2 to the right, we get this graph, and it will be the blue graph, and that will be our answer for that. Question 8, we need to find the coordinates of Q. So to find it, we need to find a perpendicular, well, I would say perpendicular bisector, but it doesn't pass through the midpoint. Well, it could, but anyway, if you find a perpendicular line, we can find the coordinates at Q where they intersect. So we know at point P, that's line 1, that's when x equals 0. So when x equals 0, we get y equals 5. So the coordinate at P would be 5, 0. And we know that if we want to find the perpendicular line equation, we need to find the gradient at this point. So if we rearrange line 1, we get the gradient to be minus 5 over 3. So the gradient of the perpendicular is going to be 3 over 5. So if we form the equation passing through P, we get y minus 5 equals to 3 over 5 x minus 0. And then putting this in the form ax plus by plus c, we get 5y minus 3x minus 25 equals 0. Now to find q, we need to do simultaneous equations. So we can put this in our calculator and we get y equals 11 and x equals 10. Now, question II, it says hence show that PQ equals to K root 34. Now to find Q, we also need the Y code. Well, we done it already. We got 10, 11, and we know that P is going to be 0, 5. So if we do Pythagoras, we get the square root of 5 minus 11 squared plus 0 minus 10 squared, all square rooted, and we get the answer to be 2 root 34. Now with part B, we know the diameter is 2 root 34. So actually, there was another question before that. So the question before that was to show that it was in the form a and minus 17, and we need to find the value of a. So to find the value of a, what we can do is substitute y equals minus 17, because we were given that the point was a minus 17 and two tangents were drawn at that point. So if we substitute minus 17 into both these lines, we can get a coordinate at, well, I'm just going to pretend that this is minus 17. So we can get a coordinate at here, and we can get a coordinate at there. So if we draw a circle here and we find a midpoint, we will find a center. So that's what we did here. And we get the coordinates to be 26.8 and minus 17 and 13.2 and minus 17. So the midpoint would be 20 minus 17. So that would be your center. Now the distance from P to Q, the diameter, was 2 root 34. Therefore the radius is going to be half of that, which is root 34. So the equation of the curve is going to, not the curve, the circle, is going to be x minus 20 all squared plus y plus 17 all squared equals to 34. Now question 9, we're given this arithmetic sequence to show that x equals 5. This taken away from this has to equal to this taken away from this. So if we solve that, we should get x equals 5. Now the first term is just going to be substituting this value into here. So we have 2 times 5 plus 5, which is 15. And then the common difference, if we just find all the terms, we get 15, 26, and 37. So the difference between each of them is going to be 11. Now with this one, we're going to use the formula n over 2 bracket 2a plus n minus 1 multiplied by the common difference. So if we do that, we get n over 2 bracket 30 plus n minus 1 multiplied by 11, and then that's all less than 100,000. And then we do the same here. We multiply by 2 to get rid of the fraction. After we simplified everything, we do it the same with this equation, and we do the same thing. We solve both these inequalities to get these two ranges, and then we need to find a number that satisfies both of these inequalities, which is 133. Now with this one, we need to show that theta equals sine 2 theta. So what we're going to do is find the area of the triangle OAC. So that's going to be half OA times OC sine theta. And we know that's going to be half lots of the area of the sector. So that's going to be half multiplied by the area of the sector, which is a half OA squared theta. So if we manipulate this, we get, if we multiply by 2, not 2, a quarter, we get 2 OA times OC sine theta equals OA squared. And we know that from a trig ratio that cos theta equals to OC over OA, because we know that OC over OA is just going to be adjacent over hypotenuse. So that's going to be your trig ratio. And if we multiply by OA, we get OC the subject. So if we simplify this, we get 2 OA cos theta multiplied by sine theta equals OA squared. So we can see the OA and the OA squared will cancel, leaving a 1 OA. So we get 2 O, actually no, it's not that. The OA and the OA squared will cancel, leaving us with 2 cos theta sine theta equals to theta. And we know from double angle formula, we know that that's going to be equal to sine 2 theta. Now with the we need to show that from this question that there's a root between this interval given. So what we do is substitute pi over 5 into here, and we get a negative value. We substitute 2 pi over 5 into here, we get a positive value. Since it goes to negative to positive, it's going to have a root. Now with the next part, we need to make this whole thing equal to 0, so we rearranged it to get sine 2 theta minus theta equals to 0. We then differentiate, so we get 2 cos 2 theta minus 1. And then we use the Newton's-Raphson method, so that's going to be theta 1 minus f of theta minus the derivative of that. So we just plug it in, and then we get 1.4733. And then we can use answer to get your your third theta approximation to get 1.047. Now the next one, it's going to be factor theorem. So we're given that x plus 2 is a factor, so p of minus 2 should equal to 0. So if we substitute this, we just get all of that, and we're just going to simplify to 0 once we substitute it. And the possible graph, well, we know that it's going to cut through the x-axis twice. So we know x plus 2 is a factor, so it's going to have to bounce at x minus 2. Or x equals minus 2, I mean. And it's going to cross at this point. Now, to find the value of b, we can use the discriminant. And we know that since it has to cross at this point twice, it has to be something in this bracket that will give a solution of x is equal to minus 2, which would be minus 4. And then next question, we're going to use the sum to infinity formula, which is a over 1 minus r. And we know that from the question, a geometric sequence has a first term 1.5. So if we substitute that, we know that we're going to get an answer of 2. To evaluate the sum to infinity from n equals 1 of sine 30 to the power n, that's sine 30 degrees. At n equals 1, we get sine 30, which is a half. At n equals 2, we get sine 30 equals to sine 30 all squared equals to a quarter. And we know that the common ratio is going to be that divided by that. So the sum to infinity is going to be half over 1 minus a half, which equals 1. And here we know that the common ratio is just a half, which I just did here. Now, with the next part of the question, we need to find the sum to infinity from n equals 0 of cos theta to the power n. And we know that that has to equal to 2 minus root 2. So we need to find the smallest possible value for theta that will give you that answer. Now, we know that when n equals 0, we get 1, because cos theta to the power 1, cos theta to the power 0 gives 1, because anything to the power 0 is 1. N equals 1 will give you cos theta. So the common ratio is going to be cos theta divided by the term before. So we get cos theta. So the sum to infinity, if we do a over 1 minus r, we get this. And then we just manipulate it by cross multiplying. So we have 1 equals 2 minus root 2 minus 2 cos theta plus root 2 cos theta. And then if we simplify this, we get cos theta equals minus 1 plus root 2 over minus 2 plus root 2, and then we find the angle by doing arc cos of that to get 3 pi over 4, and it has to be in radians. Now the next question is going to be implicit differentiation. So we need to find the value of a. We know that we were given that the distance from O to P is 16 meters. So what we do is, well, we can set y equal to 0 to find this point and this point. But since this is the origin, that's going to be when x equals 0. So if we substitute that, we get x squared minus a root x equals 0. Factorize root x, so we have x to the power 3 over 2 minus a inside the bracket. So we get these two solutions. So the distance between these two is just going to be a to the power 2/3. So a to the power 2/3 has to equal to 16. Therefore, 16 to the power of 3 over 2 would give you 64. And then to find the maximum height, we need to solve when dy by dx equals 0. So we know what a is now. So if we substitute it here and we rearrange, we use implicit differentiation. So we get 2x plus 2y dy by dx minus 32x to the power minus a half plus dy by dx equals 0. So we factorize it. We make dy by dx the subject to get this. And then we get x equals 0 and x equals 16 to the power 2/3. We substitute it back into the original equation, but we know what a is now, so we just substitute into here. And if we solve it, we get y values of 10.51 approximately and minus 11.511, but we don't take the negative value because we want the maximum height. Now, for the limitation, we know that Gary is approximating the shape of the vertical cross section. That's what the limitation they've used. Now with this one, it's going to be the trapezium rule. So it's going to be y equals 2x minus 8 ln x. So we substitute all the values in. We know h is 0.75 by doing b minus a divided by the number of strips. And we know that in the question it told us to use 5 ordinates. So the strips is going to be 4. So that's why we got 0.75. So we start at 1 because that's where the limit is starting. And we go up each time by 0.75. And then we do h over 2 multiplied by 0 plus 2 lots of the middle values. So these three. And then at the end, we get a 0 because that's the end value. And then if we approximate this, we get 5.28 to 3 significant figures. And then for this one, we're going to use integration by parts because we need to show that it's 32 ln 2 minus 33 over 2. So our u is ln x, our v is 2x minus 8. So, your v dash is 2x minus 8. So if we integrate that and we differentiate that and we use the formula, we get this. And then if we apply the limits, we get minus 32 ln 2 plus 33 over 2. But that's a negative value, so we take the absolute value to get 32 ln 2 minus 33 over 2. Now this one, we're given that y equals cosec x. So the first question was just to show that we need to show that, actually no, we had to write it in terms of sine. So cosec is just 1 over sine. We just look at the third letter. Now with part 2 of the question, we need to show that the derivative is minus cot theta cosec theta. So we use the quotient rule. U is the numerator, v is the denominator. Differentiating both, we get that. When we use the formula, we get minus cos squared. Minus cos squared. Wait, no, not minus cos squared. It will be minus cos theta over sine squared. So if we manipulate this by splitting it up, we get minus cos theta sine theta multiplied by 1 over sine theta. Cos over sine is cot, but it's negated, so it's minus cot theta. 1 over sine is cosec, so we have to multiply them together to get that. Now we need to show that the square root of y squared minus 1 over y equals cos theta. So if y equals cosec theta, then y must be equal to the square root of 1 plus cot squared theta from the identity 1 plus cot squared equals to cosec squared. Now we know if we square both sides, because we want it in terms of y squared. If we square both sides, we get y squared equals to 1 plus cot squared theta. Therefore, y squared minus 1 equals to cot squared theta. Square rooting it both sides, we get the square root of y squared minus 1 equals to cot theta. Now we know that cot theta is the same as cos theta over sine theta. And we know that we can split it as cos theta multiplied by 1 over sine theta. And 1 over sine theta is cosec theta. And cosec theta is also y. So if we plug that in here, we get y cos theta. Therefore, dividing by that y, we get the square root of y squared minus 1 over y equals to cos theta. Now, with Next question is integration by substitution. So we get that x equals to 2 cosec u. Therefore, differentiating it, we get dx equals to minus 2 cosec u cot u du. Substituting it into this integral, we get 4 cosec squared u multiplied by the square root of 4 cosec squared u minus 4, and then we multiply that by our du, which is minus 2 cot u cosec u, but we took the negative out of the integral, so that makes it easier. Now we know 4 cosec squared u minus 4 is 4 cot squared u by using the identity. So the square root of that would give you 2 cot u. So plugging that back into here, we get minus the integral of 1 over 4 cosec squared u multiplied by 2 cot u, and we multiply it by our dx, which is 2 cot u cosec u du. Now, if we manipulate this, we know that 2 cot u will cancel, and we know the cosec u will reduce this power by 1. So if we take the quarter out, we have minus a quarter times the integral of 1 over cosec u. Now, cosec u is 1 over sine, so if we just simplify that, we get minus a quarter of the integral of sine u du. So we wanted it in the form k sine u, so our k value is going to be minus a quarter. Now with the next question, it says cos u, we need to show that the integral simplifies to the square root of x squared minus 4 over 4x plus c. So we know that cos u over 4, if we integrate this, we get cos u over 4. And we know that if we use a substitution, we know that from before x is equal to 2 cosec u, so u must be equal to arc cosec of x over 2. Then we know that if we manipulate this, we get cos, well, if we substitute it into here, we get cos of arc cosec of x over 2. And we know if we simplify that, we get this. And arc cosec x over 2 equals u. Oh, so I've done all of that. So cosec u is going to be x over 2. So we use the triangle. Now we know that sine u equals to 2 over x. So that's just going to be the reciprocal of that. So if we plug everything back in, we know that cos u is the square root of 1 minus sine squared. And we know that sine u is 2 over x. So if we plug that into here, we get that, well, it says cos u, So it says cos u equals to the square root of 1 minus 2 over x all squared. So we have 4 over x squared. Therefore, cos u is going to be, if we multiply by x squared, we get x squared minus 4 over x squared. If we just simplify that, we get the square root of that. And the square root of x squared is just x. So the integral of all of this is just going to be simplified to square root of x squared minus 4 over 4x plus c. And that will be your final part of the paper.